Hello friends, welcome to Learner's Planet. Friends, this is our third session for permutation and combination. In the previous session, we discussed about factorials. We discussed good number of questions on principle of counting. And in this session, we'll be doing some more problems and then we will start actually with permutation and combination. So let's begin. Now friends, let's see this problem. Find the total number of ways in which 20 balls can be put into 5 boxes. So the first box contains just one ball. Now we have the 5 boxes, but in the first box, suppose this is the first box, we have to put up just one ball. Now all these balls, any one of these balls can be put into this particular box, right? So we have 20 choices for a ball to put in this particular box, right? Now we are left with the 19 balls and remaining 4 boxes are there. 1, 2, 3 and 4, right? Now for second ball we have 4 choices, like first ball, any of the ball we have put into this box. Now for the second ball we have 19 choices, right? I'm sorry, for 4 choices because we have 20 balls. So for the second ball we have 4 choices. For the third ball we have 4 choices. For the fourth ball we have 4 choices. Till 19th ball we have 4 choices, right? So it's 20 into 4 raised to 19, right? That is answer. And I'm sure you are clear. For the first ball, for the first box, we have to be clear that it should contain just one ball. So we have 20 choices. So I have taken 20 over here. Any one of the 20 balls can be into it. Then for the remaining balls, that is 19 balls, each and every ball has 4 choices. So first ball 4 choices, second ball 4 choices till 19 times. So that will be 4 is to 19, right? Now let's see this question. Serial numbers for an item produced in a factory are to be made using 2 letters followed by 4 digits, that is 0 to 9, right? Now if the letters are to be taken from 6 letters of English alphabets without repetition and the digits are also not repeated in a serial number, then how many serial numbers are possible? Now, so we have the code of 6 places, right? Now for the first place we have to fill up an English alphabet, that is some fixed 6 letters are there. So for the first place we have 6 choices. Any one of the 6 letters can come into this place, right? Come on this place. Now for the second place, remaining 5 letters, any one of the remaining 5 letters will come, right? So for the second place we have 5 choices. Now we have filled up the alphabets. Now we have to fill up the digits from 0 to 9. For the first place we have 10 choices because we have 10 digits over here. Now we don't want the repetition. For the second place we have 9 choices, then 8 and then 7, right? So just multiply all these numbers, you'll be getting your answer as 151200, right? So it's quite a simple problem. Now let's see this question. A customer forgets a 4-digit code for an automatic teller machine, that is ATM, in a bank. However, he remembers that this code consists of digits 3, 5, 6 and 9. So we have to find the largest possible number of trials necessary to obtain the correct code. Now friends, since the code is of 4 digit and he remembers that 3, 5, 6, 9 the digits were used, that means all the digits were used for one time only, right? That means all the digits should be distinct, all the in the code, right? So we have to fill up the 4 places with this 4 digits, right? And there should not be any repetition because the 4 digits were there and the code is also of 4 digits and we have to use all the 4 digits, right? So no repetition is done. Now for the first place we have 4 choices, for the second place we have 3, then 2, then 1. So in all There are 24 ways of arranging these 4 digits when one digit is used once only, right? So largest possible number of trials are 24. So after 24 trials, that means after 23 unsuccessful trial, the 24th trial, in the worst case, if all the 23 trials are failure, then the 24th trial will be definitely correct, right? Because no other combination is possible with these 4 digits, right? So 24 attempts will be there. Now out of the maximum failures, I'm not talking about exact failures, I'm talking about maximum failures or maximum unsuccessful attempts will be 23, right? So I hope you are clear. Now friends, let's come to the point. Now let's discuss about permutation and combination. So far we have discussed principle of counting, and we did good number of problems as well. Now it's time for us to discuss permutation and combination. See, maximum students are confused what is the difference between these two terms, permutation and combination, and where to use permutation, where to use combination, and where to use the principle of counting, right? See, do not go for any sort of rectification in this case, I must say, because all the terminologies are mutually related to each other, right? And while solving the problems, you don't have to bother which terminology has to be used, right? You just apply your normal common mathematics sense and you'll be able to do the problem, right? Because while solving the problem, you don't have to judge whether it's a permutation or a combination. You simply have to solve the problem, right? Now exactly what is the difference between these two terms, I just let you know, right? Combination means to select, right? First of all, combination is done, then permutation is done, right? Now what exact difference is? Combination is to select. Just be very clear, it is only to select, right? Combination is to select. So first of all, combinations are done, then permutations are done. In maximum textbooks and various reference books, first of all permutation is explained, then combination is explained, right? So actually first of all combination is done, then permutation is done. Now what is permutation? Permutation is to select, then arrange, right? So in combination we are just selecting, and in permutation we are arranging also. After selection we are making the arrangement also. Now this is the clear difference between these two, right? Now from our own sense we have to decide whether where is arrangement necessary, where arrangement is not necessary, right? For that no specific knowledge is given or can be given, right? We just have to apply our common sense, right? I take one or two very normal day-to-day life incidents. Now, suppose I'm giving a party at a dinner party at my place, right? And I have 25 friends, right? 25 friends. Just listen to me very carefully. I have 25 friends, right? And out of these 25 friends, I just want to call 10 persons, 10 friends for my party, right? Now, what is the event? Out of these 25 friends, I have to select 10, right? I'm not asking about any specific 10 persons. I just want to choose random 10 persons. That means I have to select 10 persons from these 25 friends, right? So I need to make the combinations of 10 friends, all the combination of 10 friends from these 25 friends, right? So this is what it's strictly to select, right? Only selection, right? Now suppose take another example. I have 3 friends, maybe 4 friends. Just take a smaller data, and suppose these are A, B, C and D. Now I wish to go to a movie and I wish to take 2 persons with me, right? 2 persons with me, right? I'm the fifth one. I'm wish to take 2 persons. Now I have to select 2 persons from these 4 people. Now what will be the combinations? A, B, A, C, A, D, B, C, B, D, C, D. So I got all the combinations. I can take AB also, AB and AC, then AD, then BC, then BD and CD. So in all I have 6 combinations of 2 friends, right? So I can take any combination, right? So here what I'm doing, I'm just strictly selecting, not arranging, because if I'm going to movie and taking suppose BC with me, so I won't see the arrangement whether B is coming first with me and C is coming, or C is coming first with me then B is coming, because this arrangement is irrelevant. We 3 people are going to the movie, me and these 2 people, right? So no arrangement is required at all. So strictly it's a problem of combination. That means we are just making a selection, right? So this is what the combination is. Now in this case only we just take what is a permutation, what is the arrangement. Now instead of going to movie, suppose I wish to give 2 prizes, that is first prize or second prize, right, to these people, right? Now what will I do? First of all, out of this 6 combinations I will select one combination. Suppose I selected BC. Now what would happen? First prize can go to any one of them and second prize will go to other person. Now what I'm doing, I'm arranging these 2 people, right? B will be first or C will be second. I'm sorry, B will be first and C will be second, or C will be first or and B will be second, right? So this B, C, this is first, this is second, or this is first, this is second. Now I'm making the arrangement, that is BC and CB, right? In the case of movie, I didn't make the arrangement here, but in the case of when I have to give the 2 prizes, that 2 first and second, right? Because first prize can be taken by one person only and second prize can also be taken by one person only. So I need to arrange, right? So this is what I am doing it. Now in the previous case, when I had to make the combination or to selection, I had 6 ways. Now I had 6 ways to make the selection, then 2 ways to make the arrangement of first and second prize. So it's 12 ways, right? So I just revise it once again. When I was going to the movie, I had 6 ways to select 2 friends with me, and when I wish to give prizes, that to first and second prizes to these 2 friends, then I have 2 more ways, 2 ways to do that. So 6 into 2, 12 ways are there. So what we did over here, it was purely a selection. Here it is selection and then arrangement, right? So this was purely a problem of combination, and this problem is combination, not only combination but permutation. That means we made the selection and then we arranged, right? This was the selection and this was the arrangement. So selection then arrangement, that is permutation, right? And just by the example you must be clear that why arrangement is necessary and where arrangement is not necessary, right? Let's take a few more examples so you'll be clear with the difference between permutation and combination. Now suppose I have 5 persons with me. These are A, B, C, D and E, right? And I wish to make a team of 2 persons to represent my table tennis team, right? Suppose I'm a coach in a college. So I have to prepare a team of 2 people. Now, how many combinations do I have? It's A, B, A, C, A, D, A, E, right? Now, B, C, B, D, B, E. Then C, D, C, E, then D, E, right? So, in all, I got 10 combinations, right? That means I'm selecting 2 persons out of these 5 people, so I'm getting 10 combinations of the 2 persons, right? So this is what I did, selection only. It's only selection, right? Now I selected 2 people out of this 5 people. So I got the 10 ways to do that. Now what would happen? Suppose I am on the playground now and I have to send one people to play, right? So I have to send one people for playing. So now I have to make the arrangement, right? Till here I just made the selection of two people, right? Suppose I selected A and E, right? Now till here the selection is done. Now, and I had 10 ways. Now I have to make arrangement which people to go first, right? Maybe A or E, right? So I have now two ways to do that. Getting my point? For selection I had 10 ways. Now to make arrangement of the order or the in which order the people should go to the playground, I have two ways, right? So in all, first of all, selection 10 ways, then arrangement of selected people is two ways. So in all, selection and simultaneously arrangement, selection and arrangement, both the things are not happening apart, both the things are going simultaneously. That means both the events are going simultaneously. That means selection and arrangement. So it's 10 into 2, so it is 20 ways. So till here, if we have to find out the solution till here, then it is strictly selection. So it is strictly combination, right? Just be very clear. To select is combination. And till here, after this step, suppose we have to come for this step, then it's a problem of permutation, right? That means selection and then arrangement. Selection as well as arrangement is permutation, right? So we are clear that to select and then here to select and then arrange, right? So this is what the difference between permutation and combination. Combination is done first, that is to select only, then permutation is to select and to arrange, right? I'm sure you are clear between the difference in permutation and combination. Now let's derive the formula for the same, right? Now let's understand the formula for combination. Friends, in my lectures, I won't be using the term permutation. Whenever it is required to arrange the persons, I'll make the arrangement, and that we will see when we'll be doing the problems, right? No need to use permutation. You can straightforward go by combinations, right? Now, the number of combinations that can be formed from n different objects taken r at a time is NCR, that is n factorial by r factorial n minus r factorial, right? Suppose you have 5 friends and out of these 5 friends you wish to choose 2 friends, right? So you have to go this way, that is 5C2, right? 5C2. Now what 5C2 is? 5 factorial upon 2 factorial into 5 minus 2 factorial. So this is 5 factorial by 2 factorial into 3 factorial. Now this we have to solve, right? Now generally if we are making combination, what is happening over here? Suppose 5 friends are A, B, C, D, E. As we have done in the previous examples, we got the 10 combinations. It is A, B, A, C, A, D, A, E, B, C, B, D, BE, then CD, CE, and then DE. So in all, 10 combinations are there, right? So if we solve this, it's 5 factorial, that is 5 into 4 into 3 into 2. This is 2 factorial, that is 2, and 3 factorial is 3 into 2, right? So we are getting 10 combinations, right? So that I have written over here. So if we have n objects and we have to select r objects out of them, so the formula will be NCR, right? The number of combinations will be NCR. And what is the expansion of NCR is n factorial over r factorial into n minus r factorial, right? See, I won't tell you the derivation over here because it will be really a time consuming process. You just like memorize this formula, that is NCR is equal to n factorial by r factorial into n minus r factorial, right? So this is what the selection only, right? So this is the first thing. Now second thing, if we have to arrange n objects in various ways, so how many ways will be there, right? Let's take an example. Suppose I have 5 objects, that is P, Q, R, S and T, and I have to arrange them at 5 places, right? So for the first place I have 5 choices, for the second place 4, then 3, then 2, then 1, right? So this is what is 5 factorial that we have already done in our previous session, that the principle of counting we were using. So these are 5 factorial ways. So 5 objects can be arranged in 5 factorial ways at 5 places, right? That means n objects can be arranged at n places in n factorial ways. Okay, it's okay. So it's n factorial ways are there to arrange n objects at n places, right? Now let's relate the two, this one and this one. Now I'm here, I'm writing down the entire incident. Just listen to me carefully. First of all, I have n objects. I have to select R objects, then arrangement of these objects to be done. Right, now go step by step. I have n objects. I'm selecting R objects, that means NCR. Out of n objects I am selecting R objects. Now till here I have done the selection. Now I have to arrange this selected objects, right? That is how many objects I have selected, R objects, and I have to arrange this R objects at R places. What will be the number of arrangements as we have just discussed, that is R factorial, right? So it's NCR. First of all I made the selection, then I made the arrangement of selected objects in R factorial ways. So both the things are happening simultaneously, so it is NCR into R factorial, the complete solution to this problem. Okay, just listen to me once again. N objects and we have to select R objects. So from N objects we are selecting R objects, that is NCR. Then these R objects which I have selected, I have to arrange them at R places. So there are R factorial ways, right? So NCR into R factorial, this is the complete solution to this problem, and it is nothing but NPR, right? That is permutation. Now you got the difference between these two. Here only selection is there, then selection, then arrangement is permutation, right? So this is selection, this is selection and then arrangement. So what is the difference between permutation and combination? Combination is strictly selection and permutation is arrangement of selected objects, right? Arrangement, this is arrangement of selected objects. We selected R objects and we are arranging R objects, right? So arrangement of selected objects is permutation and only selection is combination, right? So this is what the difference between these two, and this is the relationship between these two, right? NCR into R factorial is NPR, right? So as I had already told you that we don't have to use P and PR, because whenever we are in requirement of arrangement, we can simply use R factorial, right? If we have to make a selection, then we have to arrange the selected objects, then we can go for NCR into R factorial. No need to use NPR, right? So you will never get confusion what to where to use NPR and where to use NCR, right? You just see whether if selection is there, do NCR. If you see after selection you have to make the arrangement also, so just arrange the selected objects in R factorial ways, right? So let's do some simple problems, then we will come to this permutation combination problem, right? Now I just expand it over here. NCR is n factorial by n minus r factorial into r factorial, and into this r factorial is n p r. So r factorial is cancelled. So the formula for npr is n factorial by n minus r factorial, right? I just rewrite the both the formulae. So NCR is equal to n factorial by r factorial into n minus r factorial, and NPR is equal to NCR into r factorial, right? So it is n factorial by r factorial into n minus r factorial into r factorial. So it's n factorial by n minus r factorial. Now whatever the data given to you, the values of n and r, just put in the formula and get the answer. If only selections to be made, you use this formula. If after selection you have to arrange, then use this. Do not directly use this, you go by this step, right? The selection is done and then arrangement is done, so automatically you'll be getting this, but you won't be confused whether to use permutation or combination, right? And now friends, in examination, these sort of problems are where you have to find out the value of n, right? Here npr, that is permutation is given, right? It's simple formula based problem, so I won't be spending much time on this. We will go for the conceptual problem. I just solve one problem for you, right? Now npr is what? It's n factorial by n minus 4 factorial, right? N factorial by n minus 4 factorial is given as 360, right? Now n factorial can be written as n into n minus 1 into n minus 2 into n minus 3 into n minus 4 factorial by n minus 4 factorial is 360, right? Now n minus 1, n minus 2, n minus 3 is 360. So these are four consecutive integers, positive integers I must say, and their product is 360. So instead of solving this equation, this biquadratic equation, you just go for hit and trial and get the value of n, right? Now how do we do that? See, to get 0 over here, we want at least one number to be 5, right? Because if we do not get 5 and 2 combination, we won't be getting 0 over here, right? So I start with suppose 5. So it's 5, 4, 3 and 2. So that will be 120 only. So won't be getting 360 as product. Now suppose I take n as 6. So it is 6 into 5 into 4 into 3. So 6 5s are 30 into 4 120 into 3 360, right? That means n is 6. Simply you can solve, right? So this is what the solution of this problem, and this is just usage of the formula, so I won't be spending much time on this. Now let's go on the conceptual problems. Now let's take the problems one by one. So gradually the concept of permutation, combination and principle of counting will be cleared in your mind. Further, don't make any sort of discrimination among these terms, right? Just apply simple mathematical common sense, right? And you'll be able to do this problem, right? Now 4 books, one each in chemistry, physics, biology and mathematics are to be arranged in a shelf. In how many ways this can be done, right? Now if you start thinking it is a problem of permutation or combination or a simple arrangement, you won't be able to do it because it will be really time consuming and confusing, right? You straightforward do it, right? See, the chemistry, physics, biology and mathematics, 4 books are there. You have 4 places, right? So for first you have 4 choices, for the second book 3 and then 2 and then 1. So it's what? 4 into 3 into 2 into 1. So it's 24 ways are there to do this, right? Now if you think whether I have applied principle of counting over here, or permutation, or combination. So I would say that I have applied all the three. I can do this problem by any of this, right? Here I have just done it by principle of counting, that for the first book I have 4 choices, for the second book I have 3 choices, and for the third book I have 2 choices and then 1, right? Now if I have to do this problem using combination, what will be the strategy? Just listen to me carefully. See, I have 4 books, right? And 4 books have to be arranged at 4 places. So I have to choose all the 4 books for 4 places. So it's 4C4 only, right? If there are 6 books and I have to choose 4, then it will be 6C4. But here 4 books are then, and I have to choose all the 4. So it will be 4C4. Now I have selected this 4 books and I have to arrange these 4 books. So the selected objects can be arranged in 4 factorial ways, right? So what I'll be getting, 4C4 is nothing but 1. So 1 into 4 factorial, that is 4 into 3 into 2 into 1, that is still 24. So it doesn't matter which method you have adopted to solve the problem, either counting method or permutation or combination, right? Simply you have to solve the problem, right? Let's take one more example. Now this question, in how many ways 3 different rings can be worn in 4 fingers with at most 1 in each finger? Now further, you cannot say which problem is this, permutation, combination, or counting. Just do it, right? See, you have 3 rings and 4 fingers, right? And we have to wear only 1 ring in each finger, right? So first of all, out of these 4 fingers we need to select the 3 fingers. So which 3 fingers we will use to wear these rings? So from 4 fingers I am selecting 3 fingers, so it's 4C3. Now till here I have done the selection, right? Any 3 fingers of, right? Maybe these 3, maybe these 3, maybe these 3, whatever the 3 fingers, right? Now after selection of the 3 fingers, because the rings are different, I can wear the different arrangement also, right? Suppose the rings are of gold, silver, and maybe diamond, right? And so I can wear gold, silver, and diamond, gold, diamond, and silver, diamond, silver, and gold, and various arrangements are possible, right? Now what are these arrangements? I have selected 3 fingers, and the 3 rings can be arranged in these fingers in 3 factorial ways, right? So till here I have done the selection. Then after selection of the 3 fingers, I arranged the 3 rings in 3 factorial manner, right? So it is selection and then arrangement. So if we wish to use the term permutation, this is what the permutation is, right? And if we don't want to use that, that's perfectly all right, because we have done the selection and we have done the arrangement manually, right? So 4C3 into 3 factorial we have to calculate, right? So what 4C3 is, it's 4 factorial by 3 factorial into 1 factorial and into this 3 factorial. So it's 4 factorial only. So it's 4 into 3 into 2 into 1. That is 24 ways are there to make this arrangement. That is, first of all, to select 3 fingers in which the rings to be worn, and then the 3 rings to be arranged in these 3 fingers, right? So in all 24 ways are there, right? I'm sure you are clear. Friends, in this session I'll be taking this much only. In the next session we'll be taking more problems based on permutation, combination, and let's see what happens. Bye bye.